Hi guys. Tomorrow's class will be the last day we spend on synthetic division, and it will combine quadratics, how we've known how to solve them, and synthetic division. Basically, we're going to use both of the both of the topics, those topics we've learned to solve our equations, right? So to start this lesson, right, I'm gonna do the first step to solve this problem here, right? I have a binomial here, a linear binomial, right? Linear just means the highest power of x is 1, and I have a polynomial there. So I know I can use synthetic division, right? Okay, so now to solve this problem, right, I can rewrite this statement as such over x minus 2, right? And I can then find c. All right, this is the biggest step, the first step that all of us are very well attuned to. So x minus 2 is equal to 0. I equate the denominator to 0, and I say x is equal to 2, right? And that's the first step. So now this c is very special, right? I won't solve this problem in full just to save time on the video. But now this c is very special, and I can express it in other ways. In questions that tell you that, let me read this question. Factor the polynomial f of x equals this x cubed minus 3x squared plus 6x plus 8, given that one of its zeros is x equals 4, right? So we know one of the zeros of that equation, all right? So you've heard that term a lot in quadratics, but in the realm of synthetic division, I'm just going to tell you that when you see this term, assume they're telling you that c is equal to 4, to whatever number x is equal to, right? C in this, so here they're telling us that c is equal to 4. All right, so we just solve this as such, the same way as we solve all our equations. We get 4. We write all our placeholder values, right? Minus 3x squared is 3x. Oh, oopsie daisy. Kind of getting a bit carried away there. Let me do that again. 4 x cubed x squared x1 and x0, right? So just writing my placeholder values, then I write my coefficients. So in this case, my coefficients are 1 for my cube term, my squared term, x squared is minus 3, for x to the power 1 is minus 6, and my x to the power 0 term is 8. Right, so I bring this down, it's going to be 1 times 4 is 4, minus 3 plus 4 is just 1 again, so I have two ones there. 1 times 4 is 4, minus 6 plus 4 is minus 2, minus 2 times 4 is 8, and it's actually negative 8, and it's going to be 0. All right, and so by the way, when you are told that one of the zeros is x equals 4, every time you do your synthetic division, every time, your remainder should be 0, all right? Every time you're told c in this way, all right? Every time you're told one of its zeros is x equals 4, when you use that value of 4 as c, the remainder will always be 0. So anyway, so let me finish this expression, right? I'm going to have, here I'm going to have, this is going to be x squared, remember, just removing all of them by 1, x to the power 1, x0, and that's the remainder, right? So I can write this equation as x squared, well, actually, let me write this nicely, sorry. This is going to be Apologies. iPad issues. Okay, so this is going to, let me just rewrite that. Say f of x. And remember, we're factoring here, right? I'm just representing my equation in a different way. All right, I'm just factoring. So I have this equation, and I know one of its zeros is x equal to 4. I'm going to say this is equal to x squared. I'm getting this from here, x squared plus x plus minus, oh yeah, I'm just going to say minus 2 for speed. Minus 2, right? But now this isn't the full answer to this question, right? So we know our c is equal to 4, right? So that means we can say that the denominator of this f of x was x minus 4, right? And because I want to know what this expression would equal to, I'm not interested in the division necessarily. I can bring this 4. I'll multiply both sides, actually. Let me not cross multiply. I'll multiply both sides by x to the power, by x minus 4, x minus 4, and it will cancel out, and I'm going to get f of x equals x3 minus 3 squared minus 6x plus 8 equals, this is kind of long, x squared plus x minus 2, x minus 4. All right? We're not done, all right? Don't worry, I'm only doing one example. So ignore this question here. I'm only doing one example right now. When you see this state, when you see this, right? This equation here looks familiar. This is where your quadratic comes in, all right? You want to factor this equation and replace it with the answer you get from factoring. All right? So, in this case, a is equal to 1 in this case, right? We're doing the a equals to 1 case. And we want to factor this equation. So I'm going to have x squared, right, plus x minus 2, right? And I want to factor it. So my first step in factoring it, step 1, remember, this is equation of the form ax squared plus bx plus c. So I need to, step 1, find two numbers, right? Find two numbers that multiply to c and add to b. All right? And add to b. Multiply two numbers that add to c and multiply to b. All right? So what's my c here? My c is negative 2, right? And what's my b? My b is just positive 1. So if I multiply these, or if I find the two numbers that multiply to negative 2, right? Let me rephrase that. Now I'm finding my two numbers that multiply to negative 2. So I know I have negative 1 and 2, and I also have negative 2 and 1, right? So I'm just writing all the numbers that I know that multiply to negative 2. Okay, I see this here makes sense, because if I add 2 and negative 1, that will be equal to 1, right? So from there, I can go to step 2. Step 2, what we're going to have essentially is, let's see, what we're going to have here is x squared, oopsie daisy, we're going to have x minus 1, you see the numbers we've chose, and then x plus 2, right? So at this stage, we are done. We're almost done. So now, once we factor the quadratic equation, we put this back in the answer we found and replace the initial quadratic equation, right? We're replacing. Remember, when you factor something, you're basically writing it in a different form, so you're basically replacing it. So what we have now, our final answer, right? I know this is a bit not the best arrangement of work. Final answer is going to be x3 minus 3x squared minus 6x plus 8 is equal to, so now instead of the quadratic equation, I have x minus 1 times x plus 2 times x minus 4. All right, I'll give you an example in class. I hope this was somewhat informative and got you ready for some quadratics. We'll also look at situations where a is greater than 1, all right? So if I have an equation like 2x squared plus 5x minus 3, the steps here are different. So I'll teach you that in class. I'll remind you in class or review. We've done this before. I advise you to look at your quadratic notes, and yeah, have a good day. Bye.